So we'll take up one more. So y of t is equal to g of t into x of t. Fine. So solution, we write the system t. So input I'm applying is x of t, output is y of t, and what is y of t? G of t into x of t. So what's happening to the system? If I feed a bounded input where its amplitude is finite, what is the output? Whatever the input I feed, for that a signal g of t is getting multiplied. Okay, so let magnitude of x of t is less than or equal to bx, which is less than infinity. Then magnitude of y of t, which is equal to magnitude of g of t into x of t. Okay, so this shall I split it up, magnitude of g of t into magnitude of x of t, right? Anyhow, magnitude of x of t is bounded. How I said, because we assume that it is bounded, the amplitude, the input signal what we are applying is bounded. But what is this? What is this signal? Is this bounded or is this unbounded signal? We don't know, right? So therefore, the stability of the system depends upon the magnitude of the signal g of t. If the magnitude of the signal g of t is bounded, then the system is stable. Otherwise, the system is unstable. Okay, so system is stable. System is stable only if magnitude of g of t is bounded. Otherwise it is unstable. Fine. Take up one more. Y of t is equal to g of t plus x of t. So solution, the input I am feeding to the system is x of t and output is y of t, and what is y of t? G of t plus x of t. Okay, so let magnitude of x of t is less than or equal to bx, which is less than infinity. So then magnitude of y of t, which is equal to magnitude of g of t plus x of t. Okay, I'll split it, magnitude of g of t plus magnitude of x of t. This is bounded anyhow, we know that, we assumed it. And what about this? Okay, before that, what is the system doing? If I feed bounded input, what is the output? That bounded input signal gets added with the g of t. And what is the value of g of t and what is g of t? What kind of signal is g of t? We don't know. Fine. So here this g of t is what? We don't know. This is, therefore the stability of the system depends upon what is g of t. Same as this, right? System is stable. System is stable if magnitude of g of t is bounded. Otherwise it is unstable. Okay, so I'll take up one more. Y of t is equal to t square into x of t minus 1. Okay. Solution, so I have a system, input to the system is x of t and output to the system is y of t, which is equal to t square into x of t minus 1. Okay, so let magnitude of x of t is less than or equal to some bounded value bx, which is less than infinity. So then magnitude of y of t, which is equal to magnitude of t square into x of t minus 1. Okay, now you have to tell me whether it is bounded or what. So what's happening to the system? If I feed bounded input x of t, what's happening across the output of the system? The input signal x of t is shifted right one time. Okay, so when I shift the input signal right one time, amplitude does not change. Amplitude remains the same as the input x of t. But for that signal, what's happening? So a coefficient t square is getting multiplied, right? Now since we have t square, When t goes to infinity, infinity square is infinity. When t goes to minus infinity, minus infinity square is infinity, right? Even though x of t minus 1 at t is equal to infinity or minus infinity is finite, when I say finite, it is bounded, but t square is infinity, right? So this is actually not equal to a bounded output. Therefore, system is unstable. Okay, I'll take one last problem. Y of n is equal to, say, x of n plus u of n, x of n plus u of n minus 10. Okay. Solution. So I have a system T. Input I'm feeding is x of n, output is y of n, which is equal to x of n plus u of n minus 10, right? Okay, so let magnitude of x of n is less than or equal to bx less than or equal to infinity. So then magnitude of y of n is equal to magnitude of x of n plus u of n minus 10. I split it, magnitude of x of n plus magnitude of u of n minus 10. This is bounded, right? We assumed it. And is this bounded? U of n minus 10, is this bounded? What is the amplitude of this? It's a unit step function, right? And what is the amplitude? It is actually 1, right? This is also bounded. So both are bounded, therefore output is bounded. So therefore system is stable. You just try to take a few practice problems. So first problem, y of t is equal to e power x of t. Second one, y of t is equal to cos of x of t. Third one, y of t is equal to sin 10t into x of t. And fourth one, y of t is equal to e power minus t x of t. And fifth one, y of t is equal to e power minus t plus x of t.